Hello, I'm going to help you out on a couple of harder problems on 16.4 that people had a question on. And here's number 9. And first thing it says solve by completing the square. So first thing you're going to have to do is factor out a negative 1. So by factoring out a negative 1, we're going to be left with x squared minus minus 6 equals 0. Now, by completing the square, you would add 6 to both sides. And you're going to have x squared minus 1x equals 6. Now, if you notice, there's nothing in front of your x squared, so there's no a. So we're going to use the old formula, the b divided by 2 squared, with our b being negative 1. So it's going to be negative 1 divided by 2 squared, which equals 1/4. So what we're going to do is we're going to add 1/4 to both sides. So by adding 1/4 to both sides, now we're going to have to basically solve this. But the only thing is here is this is 6 over 1, and whenever you add fractions, we're going to have to multiply 4 to both of these, so that 6 over 1 becomes 24 over 4. So plus 24 over 4. So that's gone. That simplifies to 24 over 4 because you have to have a common denominator. So we're going to have 25 over 4 equals, it's going to be x minus something squared. Now that something, remember we take that's going to be your a, that's the square root of that. Now we have to take the square root of 1/4 to put that here, which would be 1 over 2. And it's minus because we have our minus sign there. So now you're left with x minus 1/2 squared equals 25 over 4. So now we're going to have to take the square root of both sides. So x minus 1/2 equals square root of 25 is going to be 5. Square root of 4 is 2. So it's going to be, you could say 2.5 if you really wanted to, plus or minus 5 over 2, or plus or minus 2.5. I like to use the 2.5. So x minus 1/2 equals 2.5. X minus 1/2 equals negative 2.5. So when we solve this, we're going to add 1/2 to both sides. So x equals 3, and we're going to subtract 1/2. X equals, so we're going to add 1/2 to both sides. X equals negative 2. So those are going to be your two answers for number 9. Now there's one thing that I would have done differently is that's how to solve it completing the square. I wouldn't even complete the square if I had this problem. I would just factor this out. So it would just look like, so what numbers multiply to get to a negative 6 that add to get to a negative 1? It's going to be a negative 3 and plus 2. And then when we solve this, x minus 3 equals 0, x plus 2 equals 0, x equals 3, x equals negative 2. So you get the same answer, it's just a different way of doing that. But that's how we're going to have to solve completing the square with fractions. Now, on to the next one. Reagan had a question. She said, well, I multiplied both sides everything by 2 because 18 is not a perfect square, which is perfect. So we're going to multiply everything by 2. Okay, 15. So now we're going to have 36 x squared plus 2x equals 10. So now from here, we're going to solve by completing the square. But you notice that there is a number in front of that a. So we're going to have to do our b squared divided by 4 times a. So our b is 2. So it's going to be 4 over 4 times 36, which I can already simplify that to 1 over 36 because the 4's are going to cancel out. So those guys will go away. And then we're left with 1 over 36. So that's what we're going to add to both sides. So the same thing that we did before is when you add like terms, you have to have a common denominator. So that 10 over 1, we're going to have to multiply by 36. So it's going to have to be multiplied top and bottom by 36. So that's going to be 360 over 36 plus 1 over 36, which is going to equal 361 over 36. Now this side on the right is a perfect square trinomial. So you're going to have a 6x plus, because we took the square root of this one, now we have to take the square root of that, which is 1/6 squared equals 361 over 36. So now what we're going to have to do is take the square root of both sides like we've been doing. So 6x plus 1/6 equals, so the square root of 361 over 36. So we got to take the 361, square root is 19, so that's 19 over 6. So plus or minus. So now we're going to be left with, we have to solve this. So I'm going to subtract 1/6 from both sides. So we're left with 6x equals negative 1/6 plus or minus 19 over 6. And then we got to divide by 6. So x equals 1/6, or I guess we could work that one out. So let me grab something else. So 6x equals negative 1/6 plus 19 over 6, and then 6x equals negative 1/6 minus 19 over 6. So we can actually simplify this because you have common denominators. So 6x equals 18 over 6. And then we're going to divide this by 6, which would be 3 over 6, which would end up being 1/2. Now this one, we're going to subtract these. So it's going to be 6x equals negative 20 over 6. Then we're going to divide by 6, divide by 6 over 1, which is the same as multiplying by 1/6. So that would be, so negative 20 over 6 times 1/6 is negative 20 over 36, which is going to simplify to divide both sides by 4, negative 5/9. That was one of the a tougher problem there, but that's the answer to number 15. All right, so now number 21. This is kind of thinking backwards. It's saying complete each trinomial so that it is a perfect square. So you already know what your C is. So your C is 81 over 4. So we're going to have to start thinking a little bit backwards because you know C, because there's nothing in front of here. So we're going to do our old formula, which is B divided by 2 squared. So if you notice, the 4 is 2 squared, but we got to find out what B is. So what times what equals 81? So just by thinking, we can say, hey, look, that's 9. 9 times 9 is 81. So your answer is going to be 9 and negative 9. Just because when you use this formula, the B divided by 2 squared, you have to figure out what 2 squared is 4, so that's that one. But now what times what equals 81? So that's why it's going to be 9 and 9. I hope this helps. If anyone has any questions, please reach out to me. And if you still don't understand it, let me know and we can go through a few more problems. Thanks. Have a great day.